my good student, and welcome. This is Dr. Sirme, your tutor on this platform, and I'll never let you down. Now, the KCSE 2022 is around the corner. Actually, we're just less than 50 days into the main exam. Now, many students have been telling me, oh, doctor, send us prediction, send us the hint. I'm assuring you what I'm teaching you on this platform is purely the hint for KCSE 2022. Maybe, like I predicted in the previous year, that is 2021, like paper 2, the long structured question in chemistry. Organic chemistry most likely is there. Periodic table most likely is there. Come to form 4 work, energy changes or rates of reaction will be in the papers. Just check on the solubility. It can as well be there. The industrial processes, like I have actually taught you, the industrial processes, at least one of the industrial processes will be on those papers. Do not forget the gases. The many gases we cover, at least one. Otherwise, for today, I want to take you through a simple Form 3 topic. That is the chemistry of chlorine. We are going to do the first part of chlorine and its compounds. That is the entire, a very comprehensive coverage of chlorine as an element. Welcome. Have you ever come across such products? Yes. These are common bleaches. And we use them in our day-to-day life. We also use other substances like water guard to treat waters, etc., etc. Again, do you love swimming? Are you a fan of swimming? Maybe yes, maybe no. But swimming pools are usually treated, the water for the swimming pool are usually treated with chlorine. So the chemical we are going to study, it is a chemical that we use in our day-to-day life, maybe knowingly or unknowingly. And therefore, I take you through the chemistry of chlorine. Well, the area that I'm going to cover, halogens. Yes, I will cover the halogens. I will cover chlorine as a gas, occurrence, laboratory preparation of chlorine, some physical properties of chlorine, chemical properties of chlorine, some uses of chlorine gas, how do you test for the chloride ions, and then of course I will have some good questions for you, some revision questions for you, my student. Now, I can go through the first part, the halogens. Halogens are group 7 elements. Otherwise, in the entire periodic table, we can say they are group 17. They are group 17. They include the following: fluorine, the first member; chlorine, the second member; bromine; iodine, acetylene, the very last member there. This word halogen comes from 2 Greek words. Halo, that means salt, and gen, that means producer. So basically, halogens are salt producers. They combine with metals to give us salts. Going on, we have some more details pertaining halogens. As you can see, the chemical symbols I've given you, the atomic numbers, the electron configuration. But for high schoolers, maybe go up to chlorine. For bromine, not necessarily, but it's good to know for the sake of higher levels. The ions formed, as you can see, they all form an ion with a -1. So they have a valency of 1. Even the colors I've attached for you to see. More facts about halogens. They are all non-metals. They are all diatomic. That means they form diatomic molecules. They are very poisonous. All halogens are poisonous and toxic. Yes, the atomic radius will increase down the group. This is because of increase in the number of energy levels. That is, the atom becomes bigger and bigger. The ionic radius is larger than the atomic radius. And of course, the reactivity, that is the oxidizing power, decreases down the group. The same with the electronegativity. It will decrease down the group. Some more facts about halogens. Yes, they are molecular in nature. That means they have molecular structure. The atoms are held together by very strong covalent bonds. However, the molecules are held together by weak van der Waals forces, and that means their melting and boiling points will always be low. They are non-conductors of electricity. That means they are molecular. They do not have delocalized electrons, therefore they cannot in any way conduct electricity. The next property, yes, their melting and boiling points are increased down the group, and that means the van der Waals forces, they are increasing. The strength of the van der Waals forces increases down the group. Going on, this question, maybe it's a question that my student need to know. What is electron affinity? Because electron affinity, ionization energy, these are terms that a student should know. The electron affinity is the energy that is given out or evolved when a gaseous atom gains an electron, when a new bond is formed between an atom and an electron. Yes, the electron affinity of halogens will decrease down the group. This one we're going to see as to why. Generally, as you can see that the electron affinity, the energy in kilojoules per mole of the halogens, as you can see, generally it decreases from fluorine to iodine. That one is a general trend there. Maybe we explain with these two illustrations here. Look at this first one. This is a fluorine atom, a very small atom compared to iodine atom. The fact that it is a small atom, it means the incoming electron will experience a higher or a stronger nuclear attraction as compared to iodine. Iodine is a big atom, so there are several energy levels between the incoming electron and the nucleus. So the effective nuclear charge, that is the force of attraction between the outside electron and the nucleus, is very low. Actually, we talk of the shielding effect. The many energy levels just produce what we call the shielding effect. And this means, as we talk about iodine, the energy required to gain this one electron is very minimal. But this one, it releases a lot of energy. That is, fluorine will release a lot of energy when it gains that one electron. Otherwise, a fluorine atom is more reactive because it can easily attract an external electron as compared to iodine. Basically, it's all about the size of the atom. The size of the atom. Okay, moving on, some displacement reaction of halogens. What we say, a more reactive halogen will displace halides or ions of a less reactive halogens from the solution. Like we can recall this from the previous slide, that fluorine is more reactive, followed by chlorine, bromine, iodine is the least reactive there. So like for this experiment, what we can do, we can have fluorine gas pass through a potassium fluoride, potassium chloride, potassium bromide, and even Ki solution. Or rather, I can do chlorine and I do the same in the 4 solution. I can have bromine water and I add into the 4 solutions. Then experiment 4, I can have iodine crystals that are added into again the 4 crystals and the 4 solutions. And therefore, we're going to see what exactly will happen. Well, the summary table of what will happen. Fluorine gas, yes, will not displace fluoride ions, but it can displace chloride, bromide, and iodide. They can be displaced from their solution. Coming to the next, chlorine. Chlorine cannot displace fluoride. It cannot displace itself, yes, the chloride's ion, but it can displace bromide and iodide. Bromine, as you can see again, it can only displace iodide. The iodine cannot displace any of the ions there. Maybe some ionic question and some observations there. Yes, fluorine is more reactive than chlorine. Yes, therefore it will displace chloride from the solution, and chlorine gas will be formed that will be in maybe aqueous state. The colorless solution, as you can see, it will go yellow or yellow-green there, because now aqueous chlorine has been formed in solution. The same with bromine. If I'm having fluorine gas through the bromide ions. The bromide ions are displaced, the colorless bromide ions. The solution go yellow. Why does it go yellow? Because now, or red brown, because the bromine, aqueous bromine now has been introduced into the solution. The same with fluoride and fluorine and iodine. So you can see a colorless solution going dark brown and some black solids. Maybe if it's in excess, they'll be formed. That is how fluorine will displace the three other halides. Chlorine, we've said it will displace 2. Yes, it can displace bromide. Yes, as you can see this equation, and yellow or red-brown solution will be formed because now aqueous bromine is in solution. Then we can have chlorine displacing iodides. Yes, the dark brown solution there or the black solid. Basically, what we're talking about is a displacement reaction. A more reactive halogen displacing ions of a less reactive halogen there. With bromine, it can only displace iodine, and you can see the solution there. Those are half-cell equation or rather, these are the displacement reactions taking place there. By student, you should know them on how to write them. Moving on, maybe some compounds of halogens. What you should appreciate is that halogens, they all have a valency of 1. So when they combine with various other elements, they will form similar compounds or compounds that resemble each other in one way or the other, as you can see there. Good. Some uses of halogens. We can start with the fluorine. It is used to make PTEF, polytetrafluoroethene. This is a synthetic fiber. Okay, it can also be added in small amount in toothpaste just to reduce what we call tooth decay. Well, note that too much of fluoride or fluorine in water may cause what we call fluorosis. That is the browning of teeth. So it's not good to consume water that is having too much of fluorine. Then hydrogen fluoride, yes, as you can see there, it is used to engrave, yes, picture in glass. Yep. And of course, you can go to bromide. Silver bromide is used to make photographic film. For those who are of the old age, the digital camera has just come. Before we used to have the analog one, that were using the film, and I know maybe in some places they are still in use. We move on. Iodine, something we call tincture of iodine. Something we call a tincture of iodine. It is a good disinfectant. It's a good disinfectant. Now we can move on to chlorine. Chlorine as an element. Occurrence. One point you should know: chlorine will never occur in uncombined state, in just free state in nature, because it's a very reactive element. Then it will occur as brine. This is concentrated sodium chloride that is in many salt lakes or seas and oceans. Like in Kenya, there is a lake called Lake Magadi that has sodium chloride as a brine. It can also occur as brine, that is as rock salt. Yes, rock salt. These are mineral or an ore that contains sodium chloride, and it's very common. So sodium chloride is a very common substance there, and it has chlorine. Okay, silvite and canalites, others the other ores that have some chloride in them. Moving on, we can discuss briefly how bonding occur in chlorine. Remember, chlorine is atomic number 17 with electron configuration 287, and that means one electron is lacking. That means there will be an electron pair to be shared, like I've shown here. An electron pair will be shared, and that will be covalent bond. With that, each chlorine will have 8 electrons. That is the outermost energy level there. So it's a diatomic molecule. That's a bonding in chlorine molecule. Moving on, laboratory preparation of chlorine. Those are the reagents that you can use for preparation of chlorine. Generally, you just need an oxidizing agent, an appropriate oxidizing agent that will oxidize concentrated hydrochloric acid. Like we can use manganese 4 oxide, you can use lead 4 oxide and concentrated hydrochloric acid. Otherwise, there are other oxidizing agents, for example, potassium or sodium manganate 7, potassium and sodium dichromate 6. They will still work. Remember, with the first two oxidizing agents, you have to do some heating. Yes, you have to do some heating. But with the number 3 and 4, these others are very strong oxidizing agents, so you don't need to heat. It's not a must you heat for the other two experiments. Before we proceed, a very important question for my students. Chlorine is a very poisonous gas. It should be prepared in a fume chamber or in open. Otherwise, if it's not a must, do not prepare chlorine. What I'm discussing here is enough. We have enough YouTube videos that you can see or you can watch, and you're okay, and that is the chemistry. So my student, do not prepare chlorine, especially without the assistance of your teacher or your lab technician. So chlorine, a very poisonous gas there. Moving on, the setup. Maybe you can just have a look at this setup. Okay, you need to fix a round bottom flask at this funnel there through water, through concentrated sulfuric acid, then collect the gas by downward delivery. Simply this one, you can see, as I've just discussed, the first chamber here, an oxidizing agent, concentrated hydrochloric acid. The second chamber, water. Yes, water in the second one. The third one, concentrated sulfuric acid. Then you collect the gas by downward delivery. Yes, you can see a blue litmus paper there, moist blue litmus paper there. That is the setup. Moving on, the chemical reactions that are taking place in the conic or the round bottom flask. Remember, your oxidizing agent can either be the one I've listed here. Yep, the one I've listed there. And what exactly happened is a simple oxidation process. A simple oxidation process. Hydrochloric acid is oxidized to chlorine. And of course, the oxidizing agent will be reduced to their respective chloride salts. So that is what is happening. HCl being oxidized by an oxygen from the oxidizing agent, and chlorine and water are produced. Otherwise, you can have a look at the questions just like I've listed down for you. Be it when you're using manganese 4 oxide, lead 4 oxide, potassium manganate 7, potassium dichromate 6, sodium dichromate 6, or any other. So you can see the equations I've given for you there. In every question, the salt, chloride salts are being formed. Okay, moving on. What is the role of water in the conical flask? If you can go back, yes, if you can go back to the setup, the second chamber, as you can see, the second chamber has water. That is the second conical flask. Now the question is, what is the role of this water? Why should we have this water? There it is. Water will absorb fumes of hydrogen chloride gas that are produced from or by the hydrochloric acid. Remember, concentrated hydrochloric acid is a very volatile gas. It will produce fumes of a colorless gas, that is hydrogen chloride gas. So together, remember now the hydrogen chloride gas and chlorine are mixed together. So we use water to absorb these fumes. Now, how do I dry chlorine? The appropriate drying agent, that is concentrated sulfuric 6 acid. It's the best drying agent. That's why we pass through concentrated hydrogen sulfuric acid. Yes, we pass the gas produced through these drying agents. Otherwise, we have other appropriate drying agents. Anhydrous calcium chloride. We can have a YouTube that has anhydrous calcium chloride instead of concentrated sulfuric 6 acid. We can also use silica gel. Maybe a drying agent that is not common in high school, but we do use it. Something very important you should note: calcium oxide cannot be used to dry chlorine gas, simply because calcium oxide is basic in nature. Chlorine gas is acidic, so the two automatically will react. Okay, another point: Once the gas jar is full, the gas jar we're using to collect chlorine, the blue litmus paper will change to red, and then it will be bleached. It will go colorless. So for my student, you should know, I don't need to emphasize elsewhere, that this one is the test for chlorine gas. It changes the color of blue litmus paper to red, then it will go colorless. It is bleached. It has the bleaching effect. Otherwise, another very important point, chlorine can also be obtained by electrolysis of brine. Yes, fused sodium chloride. And maybe that is at the anode. That's where chlorine gas will be produced. The chloride ions will gain, they lose. Yeah, they lose electrons to form chlorine gas there. Good, we move on. Some physical properties of chlorine. Very fast, the color of chlorine, yellow-green, or you can say pale green there. It has irritating, pungent, and choking smell. Not pleasant at all. You should know the meaning of all those terms there. It is very poisonous, just like we've said. It is denser than air, 2.5 times denser than air. And for that reason, we collect it with downward delivery. That is upward displacement of air. That is a method that is used to collect the gases that are denser than air. My students should know that. Moving on to some more physical properties. Chlorine is fairly soluble in water. Yes, 1 volume of water can dissolve 3 volumes of the gas. But when you're using the organic solvent, because we have seen that chlorine gas is molecular in nature, it will dissolve more in organic solvent like the tetrachloromethane there. It can easily liquefy if you exert some pressure. The melting point -102, the boiling point -34.3 degrees there, as I've just indicated there. Now, we go on with chemical properties of chlorine, and these are the chemical properties I will discuss very fast. The reaction of chlorine with water, the bleaching effect of chlorine water, exposure of chlorine to sunlight, yes, chlorine water, what exactly happens, the reaction of chlorine with metals, reaction of chlorine with nonmetals, the reaction of chlorine with alkaline solutions, then the oxidizing power of chlorine, the 7 of them. Very important chemistry, we're going through it. My student, go with me step by step. The reaction of chlorine with water. Chlorine dissolves in water and then reacts in it. Remember, it dissolves. Yes, it remains in chlorine molecular form, but it goes ahead to react with water to form a yellow solution that we call chlorine water. Chlorine water is basically a mixture of hydrochloric acid and chloric 1 acid, otherwise called hypochlorous acid. The chemical equation, as you can see there, chlorine reacting with water to form HCl and HOCl. Otherwise, you can still write these as HCl and O at the end. Hypochlorous acid, otherwise called chloric 1 acid. Moving on, the bleaching effect of chlorine water. This water has a bleaching effect. Chloric 1 acid is very unstable. The oxygen, actually call it the nascent oxygen. It is very unstable. It can easily be added to a dye. And when that happens, the dye is oxidized, or even a litmus paper, or even the flower petals, whichever colored substance you are talking about, provided it is a natural dye. So when the dye is oxidized, it goes colorless. Like you can see in that chemical reaction. You can see the red oxygen atom in hypochlorous acid. It is added to the dye, and of course the dye becomes a colorless. So the colored substance, whichever the color, goes colorless by oxidation. Something you should know, chlorine will oxidize by oxidation, like you've seen. It oxidizes the dye. We move on. The bleaching, still under the bleaching effect of chlorine. Yes, that is a very important point, my student, that dry chlorine gas will have no effect on a dry litmus paper, simply because chloric 1 acid cannot be formed in absence of water. So chloric 1 acid has to be formed. My student, get that and get it well. So as I've said that one, the bleaching of oxidation or bioxidation, that is Hypochlorous acid will will bleach by oxidation, yes, and that one is more long lasting. It is more permanent than the bleaching by reduction. Maybe like with the sulfite or the sulfur 6 oxide there. Very important there. Exposure of chlorine water to sunlight. Like I've done here. I have a trough with some chlorine water, an inverted boiling tube. A gas will be formed, that is oxygen gas will be formed, and of course the sunlight there. So what exactly is happening? When chlorine water is exposed to sunlight, it breaks down, especially chloric 1 acid. It will break down, and the observation, the yellow color of the solution will fade. Okay, then a colorless gas will be formed. The equation for that, the chemical equation for that one, good, you can see the yellow solution going colorless, and it is the hypochlorous acid that is decomposing in presence of sunlight, and oxygen gas is formed. My student get this and get it well. Most of the students will tend to say that the colorless gas is chlorine because this is chlorine water, but it is not chlorine, it is oxygen. It is the hypochlorous acid that is breaking down to give you hydrochloric acid and oxygen gas. That's a very important point to note, my student there. Then the reaction of chlorine with metals. Chlorine gas will react with hot metals to give their respective chloride salts. Like when I'm talking about magnesium, lowered, a burning magnesium lowered in a gas jar full of dry chlorine, the magnesium will continue to burn and a white powder will be formed. The white powder is basically magnesium chloride. The equation, as you can see there, magnesium reacting with the chlorine and magnesium chloride is formed, the white powder. If I'm talking of iron, just hot iron, it will start to glow when it is lowered in a gas jar full of chlorine. And this reaction is exothermic, you don't need to heat again, it just proceeds on its own. The chemical reaction, as you can see there. Other examples, like you can see aluminium and chlorine, sodium and chlorine, zinc and chlorine, the salts that are formed, the chloride salts. Maybe you can observe what happens when sodium reacts with chlorine. A very fantastic reaction. Okay, naturally, reaction between chlorine and sodium is very explosive. But for this one, we're going to have pieces of sodium metal. Yes, we heat sodium until it is in molten state. Then we lower it into a gas jar containing dry chlorine. Okay, you can see there a very, very fantastic reaction taking place. Yes, very brilliant. Then the white fumes you're seeing there, that is sodium chloride. Okay, and finally you can see a white powder being formed. That is the common table salt, sodium chloride. Then we talk about action of chlorine on heated iron metal. Method 1, look at that. You have a combustion tube, then you heat iron wool in it. Yes, you pass dry chlorine over it. A substance, salt K, here will be formed. We are going to discuss this. We have a gourd tube there and anhydrous calcium chloride. That is method 1. We're going to observe what exactly happens. Method 2, almost the same setup. Dry chlorine here, then iron wool is heated in a combustion tube, then a salt is formed here, iron 3 chloride. Now you can see what is the salt K. A gourd tube that has calcium oxide. We have replaced calcium chloride with calcium oxide in this setup. Then still on the same, another method of you can do the same. Remember, instead of iron, you can still work with aluminium. No big issue there. That is the setup. Again, in a combustion tube, yes, good. You have dry chlorine passing over aluminium or iron. Then a salt is formed. Far from where it is produced, a salt is formed. Aluminium or chloride or iron 3 chloride. For this setup now, we have concentrated sodium hydroxide or potassium hydroxide, and in every setup a suction pump there. Generally we'll be answering questions from such illustration or drawings there. So what exactly are we trying to do? We are trying to investigate how chlorine, that's dry chlorine, will react with either aluminium or iron metal. We move on, we discuss what exactly has happened. Iron 3 will glow red hot. That is like what we had said before. Some brown crystals will be formed. The explanation to that, iron reacts with chlorine to form a dark brown crystals of iron 3 chloride. This reaction is exothermic. So once you start heating, you initiate the heating, the reaction by heating. You don't need to heat anymore. The reaction proceeds on its own. Something very important you should know. Why is iron 3 chloride? Yes, why is iron 3 chloride formed away from where it is formed, or even aluminium chloride? That is the point. Aluminium chloride or iron chloride will sublime on heating. That is, it's a substance that sublime. So it will be formed as fumes that will go away or out of the reaction vessel or the combustion tube. Then where it is cooler, it will be deposited there. Just that, and you can see the chemical equation there. That is a very important point. Kindly, my student, get it, and of course master the equation. If we are talking about the aluminium one, it will form a white sublimate. That is aluminium chloride. That is on the cooler part. The equation is as I've given there. Remember that aluminium chloride will exist as a dimer molecule, and anhydrous aluminium, it's molecular. Unlike metal chlorides, like magnesium chloride is ionic, sodium chloride is ionic, but aluminium chloride is molecular. My student, get it. It forms covalent bonds with chlorine, not ionic. Now, if you subject it to water, if aluminium chloride is subjected to water, unlike other metal chloride like magnesium chloride that forms a neutral solution, this one will form an acidic solution. Why? It will hydrolyze. Actually, we don't talk of dissolving, it will hydrolyze to form an acidic mixture. The chemical equation, like you can see, it will form a mixture of aluminium hydroxide and HCl gas. So that hydrochloric acid in mixture, it makes it acidic. Kindly, that's something very important to note. And we have said aluminium chloride exists as dimer. That is a good review of the Form 2 chemistry there. Very important. Note that, my student. And of course, you can see two small molecules combining to form the bigger molecule. And maybe just by the way, how does the structure of aluminium chloride look like? The dimer molecule. Good. Well, a bit complex there, but just concentrate with this green aluminium here and the red aluminium particle there. So it has, aluminium is number 13, 283. So you can take the green to be the one for aluminium, 3. Therefore, it lacks 5. So chloride will donate 1, and another 1 to make 6, yes. And that aluminium will still be having 2 electrons less. So another chlorine atom will donate a pair of electrons. That is a coordinate bond. The same with this one. So, and overall the equation will be formed, the structure will be formed. So what I have just ignored is the circles, just to indicate the energy levels, but try to see that. Otherwise, if you cannot see this, observe this one. Good, there it is. You can see a covalent bond between that. Then you have a dative covalent here, a dative covalent here. Otherwise called the coordinate bond. And all these chlorides, they have 6 electrons outside, 6 of them. Here it is 4. This one has 4, and even this has 6, and this one has 6. Good. That is the structure of anhydrous aluminium chloride. My student, get it and get it well. We move on. A question here, or rather several questions. What is the use of the suction pump? Because in every setup, as you've seen, there is a suction pump. It is just to suck in the gaseous mixtures in. You know, the gases cannot force them in, but the suction will work even better. What is the purpose of anhydrous calcium chloride? A very important point. This one will absorb moisture from outside. You know, it will prevent moisture getting into the setup, because aluminium chloride, as we have seen, it easily hydrolyzes. Yep. but it has one disadvantage because it cannot absorb chlorine. So chlorine will still be exposed into the released into the atmosphere. Calcium oxide in setup 2, the same, two purpose. It can absorb moisture that prevent it getting into the setup. It can also react with chlorine, so that is better. That's better. Sodium hydroxide or potassium hydroxide in setup 3, that one is alkaline. It reacts with chlorine, so to prevent it getting into the atmosphere. And why should it not get into the atmosphere? It is a poisonous gas. We should try as much as possible not to release chlorine into the atmosphere. Precaution that should be taken when you're carrying your experiment in method 2. That one, you say that should be done in a fume chamber or in open, because calcium, that is in setup 1, I believe. Yep, the setup 1. The anhydrous calcium chloride cannot absorb chlorine. It cannot. So the best thing, do it in a fume chamber. Method 1, I think that is for method 1. Method 2, I think it's calcium oxide that we react with. Let's go there. Let's go back to that setup so that at least we can see what they're talking about. Method 2, which precaution should be taken for this one? Yes, I think calcium oxide will react with chlorine, form a mixture of salts. Otherwise, that is that. Okay. That's by the way, my student, you can also think more about that one. Yep. We go to where we were talking about the questions. This one we had responded to them. Then we move on. Reaction of chlorine with the nonmetals. For instance, phosphorus. Phosphorus will continue to burn in chlorine to produce white fumes, and that white fume is a mixture of phosphorus 3 chloride and phosphorus 5 chloride, depending. If you're using limited chlorine, phosphorus 3 chloride. If you're using excess chlorine, phosphorus 5 chloride. Note that phosphorus 5 chloride is can hydrolyze. Yes, just like we said with aluminum chloride, even this one can hydrolyze to form a mixture of acidic substances there. Phosphorus 5 oxide and HCl gas there. As you can see the equation, phosphorus 5 chloride then can dissolve in water or hydrolyzes in water to form phosphoric 5 acid and HCl gas there. We move on. Reaction with the nonmetals. Further, we can talk about reaction of chlorine with hydrogen. The two gases cannot react at room temperature. If you mix them, they will not react. And this is a reaction that you can be cautious about, because hydrogen, when it is impure, it burns explosively. So actually what exactly we do, we just introduce a jet, just controlled burning hydrogen gas into a gas jar full of chlorine gas. Then a white fumes will be formed. And for the chemical equation, as you can see there, and this one will only happen if like chlorine is or hydrogen is burning, we're at a higher temperature, not at room temperature. Like that's the point I'm talking about. This one should only happen under some special conditions, like you control the amount of hydrogen, yes, and of course this one is the key question or the reaction for the manufacture of hydrochloric acid. Reaction with alkaline solution. We start with the first category. We want to discuss how chlorine will react with alkaline solution that are cold and dilute. What exactly happens? Chlorine gas will react with the cold and dilute alkali solutions to form their respective chloride salt, just the normal salt, and hypochloride, that's what we call them, hypochlorite salts or oxochlorite salts, chlorate 1. So that's basically what will happen. The equations is what is more important, like sodium hydroxide and chlorine. You see sodium chloride, yes, it forms sodium chloride. Sodium hypochlorite, this is sodium hypochlorite or sodium oxochlorate 1, and water will be formed. The same case with the sister chemical potassium hydroxide. You can see there the chemical here, potassium hypochlorite. That is not chlorate, potassium hypochlorite with I. This one, the one I've written there. Good. With calcium, as you can see, it forms calcium chloride, yes, calcium hypochlorite, and water. The calcium hypochlorite, it's the chemical called the bleaching powder. Something to note: all these three salts, sodium hypochlorite, potassium hypochlorite, calcium hypochlorite, they are all bleaching chemicals. They have bleaching effects. That one, my student, stop the video, just check that, look at that carefully. Then we proceed. The reaction of chlorine with hot concentrated alkali solution or alkaline solution. Now the story will be a bit different. The hot and concentrated alkali solution will react with chlorine to form their chlorides, yes, but in this case it will be chlorate, yes, chlorate 5 salts. Again, chemical equation as you can see. Chemical equations as you can see. The chloride salts, the normal salts, they are there, yes, but it will form the chlorate 6 salts here. Be it sodium chlorate, yeah, 5 salt there, potassium chlorate, yes, you can see there, and of course calcium chlorate salt there. And as we said again, the three chlorate salts, they are all bleaching powder. They have bleaching effect. Like the two, this sodium chlorate, potassium chlorate, they are weed killers. They can easily kill weeds. They can decolorize the weeds and so forth. So again, stop the video, look at the equations. Very key to write, or to know how to write them. We move on. A very important note here. As we have observed, when we are reacting chlorine with alkaline solution, the temperature and the concentration is what matters. The two is what matters. The product that will be formed depends on the temperature and the concentration of the alkali. That is it. You can go back and review what we have said. We move on. The oxidizing power of chlorine. The oxidizing power. For example, chlorine can oxidize sulfite ions. If you pass chlorine gas through a sulfite solution, what exactly will happen? The sulfite ions will be converted to sulfate. So chlorine oxidizes the sulfite to sulfate. So for my student, what exactly do you need to do? Perform an experiment. Start by having a sample solution with sulfite. Do the analysis. Yes, review how you do the analysis of sulfite. Then take a sample of the same solution, pass chlorine gas through it. Okay, then do another test for sulfate. So you notice that the sulfite ions have been converted to sulfate. So maybe a chemical equation for what exactly will happen. Chlorine converts a sulfite, yep, this should be a 3, sorry for that. Then, and it will be converted to sulfate with a 4. Remember, this one is a 3, not a 4 here. Yes. Maybe that one I've told you to review. Review how you test for sulfite and sulfate. One of the videos of Dr. Sirme, I've done that for you. Good. Again, an oxidizing process for chlorine. Chlorine can react with ammonia gas, and a white fume is formed, ammonium chloride. Nitrogen gas is also formed. A chemical equation. Remember what is happening here. Chlorine, yes, is oxidizing ammonia to nitrogen, and itself is reduced to chloride. That is the oxidation process taking place, and of course the reduction process. Okay, in this reaction, chlorine is behaving as an oxidizing agent. We move on. Another reaction where chlorine is behaving as an oxidizing agent. Reaction with hydrogen chloride gas. Sorry for that. That should be hydrogen sulfide gas, not hydrogen chloride, but hydrogen sulfide gas. So what you do, you have a gas jar full of dry hydrogen sulfide. Then you introduce dry chlorine. If that happens, nothing and nothing, no observation. If you do that, dry hydrogen sulfide and a dry chlorine, nothing. But you need to introduce some drops of water, just a drop of water, and a yellow deposit will be formed. and that is the time this reaction will take place. So this reaction cannot take place until you use some drops of water, just a drop. Okay, and you can see the yellow solid that will be formed. It's sulfur. So what exactly is happening? Chlorine is oxidizing hydrogen sulfide to sulfur, and itself is reduced to a hydrogen chloride gas. A little water catalyzes. It's a catalyst. That is a key question, my student. Get it that way. We move on. Uses of chlorine. Uses of chlorine. It is used to manufacture some plastics, yes, like polyvinyl chloride. You can see there. Used to manufacture hydrochloric acid. That one will be discussed maybe in a later video. Yes, can be used to make the bleaches. Like we started with some bleaches, household bleaches. So like even sodium chlorate that is used in paper industry, cotton industry. Treatment of water, that is chlorination of water to kill germs and sewages. Another use. Manufacture of chloroform, that is an anesthetic. Yep. Then we have more manufacture of organic solvent like trichloroethane. A manufacture of CFCs, chlorofluorocarbons, a group of them. The CFC, otherwise called the freons. The freons, they can be used to as a refrigerant in fridges, in air conditioning, etc., etc. It can be used as pesticides, by the way, the CFCs. They can be used to manufacture aerosol propellants. Good. They can also be used to manufacture, that's chlorine can also be used to manufacture herbicides, that is germicides, fungicides, pesticides, DDT, among others. But for your information, some of these chemicals are not environmental friendly. That's a question to be asked. Questions on environmental conservation. Okay, that one, it's that one. How do you test for chloride ions? That is now what you should review. Solubility of chloride salts. Therefore, all chlorides are soluble except silver chloride and mercury chloride, and lead 2 chloride that is soluble in hot water. That is a solubility rule that you should know, because the solubility rules will guide us on precipitation reaction. Yes, they guide us on precipitation reaction. So we start with the test for chloride in aqueous substances or in aqueous state. So procedure, what exactly do I need to do? I place a sample solution in a test tube maybe, then I add 3 drops of lead to nitrate. Okay, so what happened? Okay, of course I warm. So what exactly happens if I do the 3 steps? There it is. A white precipitate will be formed when I add lead to nitrate. Okay, then the white precipitate will dissolve when I will do the warming. Why is it dissolving? We are talking about chloride that are in aqueous solution. We have introduced the lead 2 ions. Lead 2 chloride has been formed. That is the white precipitate. Then when it is warmed, the white precipitate dissolves. Why? The solubility rules of chlorides, again, lead 2 chloride is soluble in warm water. The chemical equation, that is ionic, that is what exactly is happening. The white precipitate is lead 2 chloride that dissolves in warming. If I decide to use acidified silver nitrate, yes, that can still work. Observation, a white precipitate that will be insoluble. So let's reason together, my student. I have added acidified silver nitrate into a solution that has chloride. A white precipitate has been formed, silver chloride, yes. Why should I have the silver nitrate being acidified? Because the white precipitate can also be silver carbonate that is insoluble as well. So why do I introduce acid? A carbonate will dissolve in the acid. So if the white precipitate is insoluble, this one, like we have stated here, therefore we are talking about a chloride being present. A chloride is being present. This is the confirmatory test of chloride ions in aqueous state. A simple next, I take you through a very simple qualitative analysis process. How you can distinguish between chloride, sulfate, carbonate, and sulfide. Okay? In one of my videos in the Dr. Sami YouTube channel, I have done this practically. So what exactly do I need? I need the unknown sample solution. that I suspect it has the 4 anions. Then I add lead to nitrate solution. A white precipitate is formed. In all the 4 cases, a white precipitate will be formed. Now, how do I distinguish now the 4? I do the step number 2. I add dilute nitric acid to that mixture. There are 2 options here. Either the white precipitate will dissolve, the white precipitate will not dissolve. If the white precipitate does not dissolve, yes, I have softer anions, either the sulfate or the carbonate. Those ones will dissolve in the acid. If they do not dissolve, then that is either a chloride or a sulfate, like you can see here. Okay? So far, I've been able to separate the 2. The carbonate and the sulfite, yes, they behave the same. The sulfate and the chloride, they behave the same. I go ahead now to differentiate between the sulfite and the carbonate. I introduce acidified potassium manganate 7 or the dichromate 7 or lime water, any of the 2. If I use the acidified potassium dichromate, yes, and the acidified dichromate is decolorized, on the potassium manganate 7 is decolorized, one of the 2, then it is a sulfite. If it doesn't, it is a carbonate. Okay? In case I use the lime water, yes, I use the lime water, and a white precipitate is formed. That is a carbonate. If the white precipitate will not be formed, it is a sulfite. But the best in this case to distinguish is the dichromate. For some reason, maybe I tend to think even the sulfur oxide will form white precipitate in the lime water. But let's not even go that. Let's use the dichromate here or the potassium manganate 7, and I will distinguish the 2. Coming to this other side, the sulfite and the chloride, I just need to heat the mixture, warm the mixture. And when I warm the mixture, a white precipitate that will dissolve. If the white precipitate just dissolve, that is a chloride. If the white precipitate persists, sulfate is present. Sulfate is a big-headed anion. It will not dissolve. So that is it. Basically, stop the video, go through what I've just discussed briefly. I move on. How do I test for chloride ions that are in solid state? Simple procedure here. I need to add, of course I have the solid sample maybe in a test tube or boiling tube. Then I add concentrated, 3 drops of concentrated sulfuric 6 acid. Remember, I can put a moist blue and a red litmus paper on the mouth of the boiling tube. Yeah, that one it's advisable. Then I dip a glass rod in a concentrated ammonia, and then I place it on the mouth of the tube. That is basically the procedure. Good. What exactly will I observe? The red litmus paper will remain red. The blue one will go red, yes. Some figures of effervescence, fizzing, bubbling of gases are being formed. Then some white fumes will be formed when I expose the glass rod dipped in ammonia to the gas coming out of the tube. So what exactly is happening? If, for example, I'm having chloride, like sodium chloride in the solution, okay? Yep. Not in the solution, this one is in solid. And then concentrated sulfuric acid, there will be some fumes of HCl gas. And the HCl gas are reacting with the ammonia, ammonia from the concentrated ammonia to form ammonium chloride. Basically, this one is the test. Yeah, the white fumes, as you can see. This is the confirmatory test for chloride that are in solid state. I don't know whether my student you're getting. We are having a solid here that we suspect has chloride. We bring in concentrated sulfuric acid. Once we bring in the concentrated sulfuric acid, it will bring out the chloride in form of HCl. That is a confirmatory. The HCl gas, how do you confirm? Yeah, expose it to ammonia, white fumes. As simple as that. I may not emphasize any more. Otherwise, we have come to the end of the discussion part. These are just some questions good for you here. I have 25 questions for you. We start with the short structured questions. Yep, question 1. You can see that. A nice question, kindly go through it and attempt the question. Question 2, another good question there, a diagram there, preparation of chlorine. Question 3, yep, a nice question again for you, still on preparation of chlorine. Yes, we move on. Question number 4. A student there, Mani, is trying to prepare chlorine. Go through the question, a nice one for you. Remember, in case you're not able to answer the question, refer. Yes, refer to the notes that I've just discussed. Question number 5, yes. Question number 5. A nice one, a flowchart, a question that you can attempt, my student. Good. Question number 6, a nice question there for you. Yeah, a question on, I think, environmental factors. Yes, environmental issues of chlorine. That's very key, my student. Always mind, when you're dealing with elemental topics, mind so much on environmental factors. We go question 7 and 8. Nice questions there. Read the question, stop the video, attempt the question. Question number, we go on. Question number 9. Yes, question on halogens. Question number 10, you can see a question displacement reactions of halogens. A nice questions for you there. We go question number 11 and 12. Short structured, we're still talking about short structured questions. We go on question number 13 and 14. You can read the question, attempt the questions. Question number 15, 16 and 17. Still on chlorine and compounds. Nice short structured questions there, my student. Good. Question number 18 and 19 there. Yes. Question number 20. Good. That's the end of the short structured questions. Good. Question number 21. That one you need to study the setup that you've given there for preparation of chlorine. Then answer these questions. Part A, B, C, D, E. Yes. And remember, these questions are just repeating themselves. The questions will keep on repeating themselves until you get it. Question number 22. A nice question again, long structured. Yes. Yep. You go on. There are questions for this one. Yeah, you can see the setup is there. And of course, a good question there. And as you can see, these questions can also be intertwined with even the whole concept, etc., etc. Then question number 23. Yes, question number 23, part A. Question number 23, part B. Like this one, it's similar to the question that was there before. Yes, question number 24. Question number 24. And question number 25. Good. Otherwise, that is the end, my good student. Thank you so much for watching for the 2022 candidates. I wish you all the best. I know the 2nd of December, that's the time you do the paper 1. Then the 6th of December, you'll be doing the paper 2. And the 9th of December, you do the paper 3, the chemistry paper 3. I wish you all the best. I had given you the hint, and I'm telling you the chemistry that will be in those papers is all that we are discussing here. Otherwise, do not forget to subscribe, my student. If you have not subscribed, do not forget to recommend to other students that they may watch this content. And I love you so much. Thank you, and all the best.